Wait for the recording.
Got it.
All right, thank you so much, Frank.
Right.
And it's lovely to be here and well, at least be in the same Zoom call with all of you. I can't see your faces, unfortunately, but it's nice to see some familiar familiar names. Okotas here, Paul, Sigu, yeah, some others. All right, so I was asked to jump in today to give you this little talk about my monoliths for this microservices. Oh, Jackie's there too, my coworker. Hi, Jackie. And yeah, let's. So first of all, we talk about Elixir, so I have to put on my Elixir hat. Not sure whether you still have before. Nice. 1 second.
It's really cool.
Gonna get one.
Makes me look like a baseball dad, but it's okay. All right, let's get started. First of all, before I start the talk, if you have any questions, please feel free to interrupt me. Raise a hand. I can't see Zoom, so I'm gonna rely on Juliet and Frank to just interrupt me if there's a question. Otherwise, I will also, during the talk, I will give you plenty of time to ask your questions as well. So if you don't want to ask right away, just wait until that, and then I will answer them. All right, let's start. I'm gonna share my screen. All right, so yeah. Today, we will talk a little bit about monoliths with microservices, and I will just give you a little review, my own view on these two different architectures and what they're good for, what they might not be so good for, when to use which, and so on. So I'm Peter Ullrich. Most of you might have seen me in person already. I visited Kisumu at least 2 times. Kenya is still one of my most favorite countries. So I will be back soon, hopefully again. And sorry, yeah, you can find me on Twitter. That's where I'm most active at PJ Ullrich, or I also have a personal website, peterullrich.com. So a little bit about me for those of you who haven't met me before. I'm from the Netherlands, but I'm German. I live in the Netherlands though. I work currently as a senior Elixir engineer at Remote. Used to be team lead here too, but I went back to IC because I love to write code. On the right side is me with my motorcycle. I love to ride the motorcycle, but like big tours, not just Sunday afternoon runs. And this is me in South Africa, where I drove down all the way from Egypt through Sudan, Ethiopia, Kenya. Then I had Tanzania, Zambia, Botswana, in this case, down to South Africa. That was the one tour. And I also toured South Africa, Zimbabwe, Zambia, Namibia in 2016. So I love to do these like long tours whenever I have the chance. Yeah, so yeah, currently I work at Remote. You might know Remote. Before that, I worked for a German company, which is now called JobDeli. And I will tell you a little bit about these 2 companies in a second. So yeah, as I said, Twitter, PJ Ullrich, and my personal website is peterullrich.com, where I write blogs quite often if I can. I'm currently working on a video course. So I don't write that many blog posts, but yeah, every now and then I post something there, and I think people quite enjoy it. All right, so let's get started with the talk. I will talk about monoliths with the microservices, which architecture is right for me, for you in this case, and how to implement them with Elixir in the second part. Now let's talk about some use cases first. I worked at a company called JobDeli where we had 25 plus microservices. They might be good in the 40s or 50s by now. We had different, like each team, we had like, I think 6 or 7 different teams. Each one of them had 3 to 8 services, sometimes up to 10 services. So quite a lot of them. 6 teams at the time when I worked there. Our stack was very simple. We just had Heroku for the deployment, Elixir, and we used LiveView for most of the internal apps, but also for some customer-facing apps eventually. And we also had some React apps they were mostly used with Ruby and Rails, and then React as a front end. And then we had the Elixir stack, which was actually just Elixir and LiveView. The company had 2 previously failed monoliths. They went through a Python monolith, a very big one, which then eventually they could not longer develop because they had too many entanglements, too many edge cases. It was too spaghetti code, so to say. Everything was connected to everything, and if you changed one thing, everything would break. So they found themselves in a bad situation and decided to get rid of the Python monolith. I believe before that they had another Python monolith, and then that Python monolith, and then they decided on microservices with Elixir, and first Ruby, and then also Elixir. So there was a lot of history in that company. And the company is now, I think, 12 years old or so. It's, you know, stable, pretty established mid-growth company. It's not like a hyper growth startup or so on. So this is my first employer. Now my current employer is remote, or remote.com, the URL. We have one giant monolith. Jackie and I push code to that every day. And yeah, it is interesting. We have some problems, like because we don't have the separation as we have microservices. The teams overlap a little bit, and sometimes you have teams working on other people's code. So it's good, but it could be improved. And yeah, we have 20 teams or so. Actually, I don't know the exact number, but like 100 and something engineers. Our stack is a bit more conventional, I would say. AWS for deployments, Elixir for the backend, and React for the front end. And it's 4 years young by now, and we are hyper growth. So we scaled, not right, maybe still we are kind of hyper growth. Last year was a little bit more difficult for everybody, but I think we are back on track to the hockey stick growth. So yeah, it's going quite well. So you see these different companies have different requirements in that term already, because we have like currently a hyper growth startup. A lot of things need to be shipped fast. We need to be very agile. And in my last company, we could take a little bit more time to, you know, spend more time on maintenance, or yeah, we didn't have that much pressure there. So that's already one thing that I will talk about later. Now, let's talk about the microservices I had at Job Valley. The pros of those were that we had very hard boundaries between the teams. And that was quite important, because the company Job Valley did a little bit similar things as remote. So we had basically students, and they were working for us, and we rented them out, which is called temping, to companies that needed to have cheap labor for a couple of hours. You know, like we had companies like retail stores for clothes, for example, and they needed to have a couple of students to count their inventory, you know, to do inventory on a weekend, for example. So they needed to have cheap labor students in this case, but only for a day or two, maybe a week or two max, but so not full-time employed. And that's where we came in. So we provided these students and invoiced the companies and paid out the students. So as you can see, we didn't make a lot of money per student. So we had to grow into the width. We had to take more students and rent them out for shorter periods of time. And that means that the entire system needs to be focused more on this throughput. So you have a lot of individuals coming through the system. We had a lot of students who only worked for us once. We still haven't figured out why, but that has been like, it was different. So we had a lot of different individuals coming through the system. And yeah, these hard boundaries in the teams helped us to so allowed the teams to really only focus on their own domain. So they could think about only payroll, and then they could optimize for all these students coming through payroll. And then we also had other people like offering the jobs, for example, to the students. They could also focus only on their part and didn't really have to worry that much about the other teams. So it made us quite independent of each other, which was quite good. This is in developer terms quite important. So we had code and schemas which didn't interfere, because every team had their own microservice with their own schemas and their own code. Previously, the Python monoliths that they had in the company, you had very huge schemas which contained a lot of information for a lot of teams. So if you think about a student schema, for example, you know, we have payroll, we have invoicing, we have temping, time and attendance. Like we have a lot of different teams that all see a student differently. You know, for the payroll people, it's a person we have to pay a salary. For the invoicing people, we need to know how much the student worked in order to invoice the company correctly. Time and attendance, we needed to know when and where the student worked, for example. And a lot of different things. So previously, the big problem in the previous monoliths was that the code interfered a lot with each other. So you had huge schemas in the middle, and then everybody needed that schema to do their job. But because every team had different requirements and different needs for the student, they were interfering with each other. And later on with microservices, you could split these things into your own schema. You only store the data you need. You have full control over that data, and you can really optimize it for your use case. So that's a very important distinction here. Now, all of that made our teams quite independent. We could, as a team, work mostly independently, think about our own roadmap, didn't have to communicate that much with other teams. So we could have our own speed and didn't get blocked by other teams because we had to wait for them to build something for us or answer a question we had. We could deploy independently. It's also quite important. We had microservices that were quite small, and you could deploy them in like 10 minutes, all of it. Like you push your code, and 10 minutes later it was online. And that was great if you had a bug or you needed to, make a quick change. And that is a little bit different at my current company, where we have a huge monolith, and deploying takes up to an hour, usually up to an hour, sometimes a bit more. So if you want to just fix something quickly and see whether your fix works, well, good luck. You can come back an hour later. Yeah. That is important. So we had a job value, the microservices, and we could scale them independently. We had a few microservices in the middle where we had a lot of users, like the students, for example, coming in, but we also had internal users using the same services. And these services we could scale independently. We could have 3 of those and have a horizontal scaling situation. And with others, we literally just needed a single server, like the smallest possible version on Heroku that doesn't get shut down for like $7. So that was also good for us in order to improve our costs, our server costs a little bit. Yeah, this is an interesting one. So the pro of the microservice here was that because we split all these systems into different microservices, the teams had to communicate with each other, like about how to communicate between the services, right? So how do you get data from server A of team A to server B at team B? And what we used is we used GitHub, a GitHub repository, where we defined events. So whenever something happened in service 1, like a student signed up, for example, with a first name, last name, and email, and maybe address, that server threw an event or like published an event. And these events, they were defined. So we had a definition for that in the GitHub repository. We made sure that every event that was fired also adheres to that definition. And this way you have 2 advantages. The downstream teams who subscribe to these events, they know for sure which data they will get. They can plan with that, they can work with that. But also they can, in the beginning of the work, they can communicate with that team, like with team A, and say, hey, team A, I see that you want to publish this event and you want to have the first name, last name, and email address in that event. But I also need the home address, for example, of the student, or I might need the bank account number, right? So in that way, the teams that come below, like that come later, they can tell the first team and also any other team what they need. So the dependencies between the teams also became more open, more transparent, because you had that connection. It wasn't, because if you have a monolith, all you need to do as a team is like to query to read the right data, right? You get the student and you get exactly the data you need. But that is like, it's in your code somewhere. And now another team might come in and realize, hey, why do we need the bank account? We're just going to get rid of that, delete it, right? Or not fill it, just leave it nil. And then your team has a problem. And it's like, with these events, you have a very clear, transparent, and public conversation and communication of what you need. So that was a great win for showing the dependencies between the teams. Yeah, an advantage of the microservice here was also that we can delete code without worrying about other teams. So if we had a first version and then we iterated and we had a second version, no problem. We can get rid of the first version. Nobody else depends on our code. As long as we publish the right events, everything is fine. So we can even shut down services, as long as nobody else is reliant on that event. And yeah, it was very interesting for a use case where we had to replace an old monolith. So we had an old Ruby monolith that was written in like Ruby 2.2 or 2.3. and we couldn't upgrade it anymore to the latest dependencies, to the latest version. And yeah, we couldn't really develop with it anymore. We had all these dependency problems, conflicts, and we decided either we spend a lot of time to upgrade this monolith to 2.6 or 2.7 at the time, or we gonna slowly replace it with something new, with this new microservice architecture. And there is a pattern for this. It's called the Strangler Pattern. And Strangler Pattern comes from this Strangler fig tree, or like the Strangler fig, which is a plant, and that is a parasite actually, and it goes around the tree, and it slowly grows around the tree, and unfortunately kills off the tree that is underneath. And then once it's big enough, it is strong enough to support itself. So that's the Strangler fig, and you can use that. Well, it's a pattern for replacing old infrastructure, where you have a monolith in the middle, and then you pull out small components from that monolith into microservices or another monolith, right, into a new service. And you pull out like piece by piece into the new service until you can safely kill off the old service. And we used that with microservices because we had this old monolith, and then we pulled out different components into new microservices. And then eventually when I left the company, we weren't quite able to kill off the old monolith, but we were getting there. There was a roadmap. So microservices are great because you can just pull out the components into a new microservice and then scale it and make it independent and everything. Yeah, so you can do the same with a monolith, but then you migrate from one monolith to another monolith, and you might make the same mistakes again. So it depends on the situation. All right, one last thing, the business process flow becomes visible through the events. So this is very important if you work in a larger company, because in a larger company, it is very difficult to understand how the entire flow through your software looks like and works. Like in Job Valley, we had the students, and the students they sign up for different shifts where they want to work. They go to work, they register that they work, and then we invoice that and we pay them out. Like it's a whole process from start to end. And if you have a single monolith, the only way to see that is, I don't even know, like through looking at the code. But then you might have different requests coming in. So first the sign up request, then the sign up for shift request, and so on. So it's very hard to look from the outside onto your software and see what happens in which order. Like, does the student first sign up and then sign up for the shifts, or something else? Like, do we first invoice and then pay out the salary, or do we first pay the salary and then invoice? These are two things. So it's very implicit and hard to see in a monolith how the business process flow looks like. But it becomes very visible once you have microservices and you rely on events between these services, because you can analyze the events and you can see, all right, this event is first published. It is consumed by that service. That service publishes that event, which is again consumed by this service, and so on. So by looking at this event flow, you can see how the business works. And I found that really interesting because you can, see the dependencies between the teams, and then you can optimize for that and so on. So it's quite interesting. All right, but so many pros about the microservices. Obviously, there are also some cons, otherwise everybody would do it. The first one is DevOps is much harder than with monoliths. So deploying, as I said, per team, we had like 3 to 8, sometimes 10 microservices. We were quite fast with creating microservices. It took like a day to set up a new microservice, and then we had to have all these different GitHub repositories and so on. So usually, if you don't take care of reducing the amount of DevOps necessary, your team will need to do that much more. They will need to maintain the servers and see that they don't crash and so on. So instead of having 1 or 2 servers, you immediately have 10. And then you need to maintain them. So it's much more difficult. But that can be mitigated. In our case, we used Heroku, which was very user-friendly. We didn't really need to do much. Just click a button, you get a server, it's managed. Don't worry about it. it was so easy that every developer could use it and deploy a new service. Easy. You don't, but you know, in my new company, we use AWS, and honestly, I don't understand AWS. I couldn't deploy anything if my life depended on it. So in that case, we used Heroku because it, you know, took away that problem. Yeah, if you use a standardized stack, so every service we had Elixir and LiveView. That was it. No React, nowhere. And so we had Ruby and React, and we had Elixir and LiveView. So I only took care of the Elixir LiveView service. And because every stack is the same, we try to bump the version numbers with every app, you know, so it was quite standardized. So it was easy to fix a problem if it appeared somewhere. Yeah, as I said, it took 1 day to set up a new service. Yeah. Now, the next problem with microservices is if you query data across different services, that is not easy at all. If you have a monolith, you have a single database mostly, you have the same schemas everywhere, you can just write your query, get your result, done, right? But if you have microservices, you might also have, if you have 10 microservices, you will have 10 different databases, and each one of them will contain different data, maybe in a different format, and so on. So if you need to query across all of them, it's not possible unless you really write some code. Like you can't, with Postgres, you can't connect to different databases and have queries between these. You know, it can only be one database. So yeah, eventually we built like some small Elixir apps that could at least query the events from all these different services to see what's happening, but that already took quite some time. So this is a downside, definitely. Yeah. This is also a problem for your service itself. Like, let's say I have a service somewhere in the back of the whole chain of services, and that one needs some data from the first one, and it didn't get that in the event. So it needs to make an API call, get it, right? And now we have a second information piece that we're missing. We need to make another API call, and so on. And that can really spiral out of control very quickly. And eventually you might have a user just trying to read their user profile, and you have like 10 different fields in the profile, and you need to make 10 different API calls from different services to get all that data in. Where with a monolith, you just make a single call, right? That's it. So that is something where you really need to watch out that either every service has all the information it needs, or you reduce these kind of things. Yeah. So we had a situation where we couldn't show the name of the user in the navbar, because then we would need to make like a call and another call, and we decided against that. So like you could only see like you're logged in, but not like Peter is logged in, for example. Anyway, yeah, the downside of microservice is very easy things can become difficult quite quickly. And one of them is authentication. You know, with a monolith, you have a single authentication mechanism. You sign up, you have a cookie, and every request you make to the monolith is signed with the same cookie. Now, if you have 10 different microservices and you sign up for you log into the first one, how do you manage to also sign up to the other 9? And there are ways around it. We eventually reuse the same cookie with every service. And internally, like if you have the service lying further down, you don't need to worry that much about the user authentication. I mean, you still send it and you authenticate the call, but like if a user logs into the first service and that one calls another one, like that one, you don't need to, in our case, we didn't need to authenticate it. But yeah, so authentication with front-end apps, it can be difficult. Unless you have a React front-end, for example. With the React front-end, you just make a single sign up, and then but still then you have like 10 different services you need to authenticate with. So it's not easy. All right. Even stuff like shared CSS is not easy, because if you have 10 different services, all with LiveView, and they should have all the same CSS, you know, you don't want to copy paste the CSS from app A to app B to app C to app D every time you make a change. Like if you change the color of a button, you know, you don't want to copy paste that to all the applications. What we did eventually, we had an npm package that we can pull from the npm package manager, and in that we had our design system, so to say. So, you know, when you change the color of a button, we tested it locally, and then we pushed a new version to the npm store. And whenever a service was restarted, it pulled that package, and this way we had the same styling everywhere. But usually you have a single monolith with a single CSS, and it's not a problem at all. Yeah, and that all means that the development speed can slow down. Doesn't need to, depends on many factors. But if you think about these things, yeah, you will spend more time on DevOps. You will spend more time on thinking about how do you do authentication, how do you code sharing, and so on. And immediately you have to think about many more things than only a single server. And one last part is, yes, product-wide testing is very difficult. So like manual testing, it's fine. You can click through the UI and it should work. But if you have automatic testing, like a user signs up for a shift, goes to work, is paid the salary, and we invoice the company, that is not possible in an automatic way. Like unless you really write a lot of code specifically for that. But yeah, with the monolith, you have live view, you write one test case, done. Or like one test case that goes through every step, done. Or you have something like, what's it called? Not Selenium, but the end-to-end test frameworks, right? You write it in JavaScript and it literally clicks through the browser and it's done. Like, I feel like the Nairobi cook on TikTok always says like, you chop the onions, done. You chop this, done. Anyway, you know what I mean.
Mm-hmm.
Okay. Well, that has been everything about microservices. Are there any questions?
Yeah, there are actually 2 questions on the chat. So Alfonso Gonzalez was asking, if I got it right, he's saying, what are some of the comparatives, what are the pros and cons between separated GitHub repos and umbrella apps, which are then deployed as separated services?
Okay. To be honest, it's an interesting, I haven't thought about using an umbrella app and then deploying it as separate services. It could work as well, but even then you would have a single code base, and that's sometimes good, sometimes not so good. It's like, you have like both in one. You have a single code base, which usually is a monolith, and then you divide it up into different services. So then you deploy them differently. I don't know, it sounds interesting. I haven't used it. I'm not that familiar with umbrella apps. I just know that some people in the upper echelons of the Elixir community, they say, unless you need umbrella apps, don't use them, and you know when you need them. So in our case, it was easier to have separate GitHub repositories, because that also for the engineers means that there's a mental split between different services. And this mental split, I think, is even more important than an actual code-based split. Because if you think about it, like we use domain-driven design, it's a whole different topic. But basically, you break your software, your system, up into smaller contexts. Like you have the payroll context, invoicing context, and so on. And that was really important to us because we had previously all these interferences between these domains. And with the code and the microservices, we could split it, and it had to be split. And there was no way you could not split it, because there were different code bases. And especially if you have many teams, that is an advantage. That's what you want. Like you want to have that independence, and you want to make it hard, like a hard split. So this advantage is very interesting. I haven't used it. I would need to read more about that. Yeah. Second question.
Still from Alfonso. How do you tackle if for some reason the process took to deploy a microservice sending wrong structured messages to another service? And how do you fix those sent messages?
Yeah. In our case, we used RabbitMQ, and RabbitMQ does not persist messages unless unless they're they're successfully processed. So when we deployed a microservice that sends irregular, broken events, these events were like, we tried to consume them, but we couldn't. There was an error. right? You get an event and you expect a message, and you expect some data, and the data isn't there. So we actually threw an exception and just sent back the event to RabbitMQ and said, we can't process this. Then RabbitMQ retries 10 times. And if it retried 10 times that particular event, it will put it on a dead queue. And that's basically where these broken events end up. Now that is already a point where, you know, you at least have your broken events not inside your database of that service. So it's fine. Our mitigation, what we usually did to solve these things was we resent the events that were broken. So we, you know, deployed a fixed microservice. We manually, with a script, send only the events we wanted to send. And then at the new service, you know, we consumed them. Also, another, you know, thing that was helpful is we had every event being, what's the word for it? Not ephemeral. Anyway, but it's like if you consume the event once, you know, you change something in your database. And now if you consume the same event again, you don't do anything. You know, like in that way, we wrote our event. So if you get an event 1 or 2 or 3 or 4 times, it didn't matter. The end state would always stay the same. And that helped us with fixing this, because if you had like 100 events and only 90 of those were broken, you could just resend all of the 100, you know, with the fixed payload. And the 10 that you already consumed, they're no up, like nothing changes because of them. So that was important for us too, to have this characteristic, which I forgot now, but the way you can consume an event again and again and it doesn't change anything. So yeah, we send the events basically. That's the answer. All right.
Very good.
Thank you, Alfonso. Good question. All right, then let's move on, I guess, to the monolith. Now we are going to remote to my current employer, and we are going to talk about the monolith that we have here. First of all, the pros of it. We are a hyper-growth startup. We need to iterate quickly. We need to change quickly, fix bugs quickly, everything. So it was a very fast off-the-ground approach where you have only a monolith, and then you keep adding to the monolith. Even if you get new teams, you just add them to the same monolith. You don't need to explain the architecture of your software. Like if you work with Elixir, we had a where we use Phoenix like everybody else. We have some special things like services and like some special software design, basically, but that's not too difficult to understand. So, but basically, if you had a new engineer, a new Elixir engineer that came in, they understood how Phoenix works. They understand what a controller is, you know, what a schema is. So you don't need to explain much. They are onboarded quicker than if they would work for a big company where you have a giant software architecture that you need to understand first. So that was important to us from a technical perspective, where we can write our code quickly, but where we can also onboard new developers quickly. So that was important. I think we added like 80, or we tripled our engineering force in a single year, I think something like that. So that was important to us, yeah. Now, it's easy to deploy and scale. Well, I'm saying that. If you ask our DevOps team, they might disagree. But we have AWS, we deploy to it. We have like 2 or 3 replications, done, right? Not too difficult. And of course, if you need to scale it, it's a single click in AWS and fine. Yeah, so it's better for product-wide testing, although we don't do it that much. But we have some tests that go from one team to the next, like that test different parts of the software in a sequence. Like, for example, an onboarding process. You know, somebody signs up for the system, and then we need because we work with. Sorry, I haven't explained that before. The company that I and Jackie work for, remote.com, we basically help employees. So if you're a company, let's say in the UK, and you want to hire Kenyan developers, all right? Usually what happens now is you work as a contractor in Kenya and you send your invoices to the UK company and you get paid in US dollar or whatever, through M-Pesa maybe. And, you know, it's okay, but the problem there is, as a Kenyan contractor, you don't have any job security. You don't have any benefits, all these kind of things that you usually have when you have a full-time employment with a company. So that's where, and now you might ask the UK company, hey, can you please hire me full-time, like as a full employee? I would like to get a pension and health insurance and everything. And the UK company says, no, there's too much work. You know, you would need to set up a legal entity in Kenya and hire you there, and it's just too much work. So that's where we come in as remote. Like, we are the intermediary. You know, we hire you officially, legally in Kenya, which I understand it's not what a lot of people want in Kenya, but in other countries, that's what people want. And then we hire you officially with a contract and everything. And we basically invoice the person in the UK, the company, and you can work for them legally. You're legally employed, you know, can get a mortgage easily, or something like that. So that's what we do as remote. Now, if we go back to the product-wide testing part here, it's important because now you are the Kenyan developer and you use us remote for the contract. We need a lot of information from you. You know, we might need your name, your birth date, your address, your bank account, your certificates you have, any like health certificates or whatever, like that, a lot of different things that we need from you. And that's the onboarding process. And we want that onboarding process to always work for you, right? You should not sit there and not be able to fill a field for whatever reason. So that's why we do product-wide testing in that case, where we test the entire onboarding from start to end. And that's only possible because we use a monolith. Otherwise, we would need to set up a whole infrastructure for that, and that would not be worth it. So product-wide testing is easier in a monolith. That's the point. Now, it's easier to enforce code conventions and practices across the teams. That is important, especially to us, because as I said, we increased our headcount a lot very quickly. New engineers came in, and you know how engineers are. Everybody has their own opinion about how things should be done, and everybody knows the one single truth to how you should structure your code and what dry code is and so on. So in our case, it helped us, the monolith helped us to enforce these code conventions, where we say, you write a controller like this, and you always have to put the definitions here. And the schemas need to have that name, you know, or look like that, and so on. And yeah, that helped us a lot. Not only for the code conventions, but also for testing, like how do you write tests? For example, we actually have that where now our monolith is so big that we have problems compiling. It sometimes took like 15 minutes to compile the entire project. So we have a whole team dedicated to improving the compilation time of Elixir, of this project. And one or two very smart engineers from us, they already contributed to the Elixir, the code base, to improve the compilation time there. And this is stuff like that we can implement locally and test it locally first, and then contribute to Elixir, for example. And that's only possible because we have the monolith, right? Otherwise, you might only have smaller code bases, or if you change one code base, not all the teams will prosper from it, will have a benefit, you know. So there are different things that make these things easier. All right, that's a little bit what I talked about, the fundamentals. Yeah, if you have like 20, 30 different teams as we have, you need to have some fundamentals just laid out for the developers to work on, like authentication. You know, not every single team should have to worry about authentication, should implement their own authentication. Like, you want to have a single way to authenticate. And yeah, a lot of teams don't need it, right? You just want to, in my case, I work in payroll. I just want to focus on my payroll product. I don't want to worry about having employees or my users sign up. So that stuff. Event tracking, same, you know, whenever we change something in the database, like whenever we change a user, you know, change the username, we track an event, we just save an event. This changed from Peter to Patrick or something. So that's also a fundamental that every team needs, but not every team should have to worry about that. So a monolith makes it very easy. Now, again, you know, if you ever work with a huge monolith, there are some cons. So let's talk about those. This is something that I talked about earlier. It's hard to spot the InterTeam dependencies. I talked about the business flow through the entire process. Like in our case, we have employees, we onboard them, they start working for us, they might get a new contract, they might, you know, stop their contract, stop working for the company. And that's the whole life cycle of an employee, basically. And we have, as I said, like 20 to 30 teams. Every single team has some point in that life cycle that's important to them. And to understand how that all works together, I think nobody has that full picture. And because it's a monolith, we can't really analyze that either. We don't have events, we don't have a formal communication way between these teams. It's just you push it into the database and another team retrieves it again, you know. So it's hard to spot these inter-team dependencies, and it happens that one team changes something and breaks the part of another team. You know, the other team they have to do some bug fixing or so, and that happens, especially in fast-growing companies. Right. Yeah, that's one of the great things. I will just use your schema and won't tell you about it. It's amazing. Like, you know, especially in a company with like 150 or so engineers. Yeah, you know, they need to develop a feature. Another team needs to develop a feature. They see, oh, you have the information I need, right? I'm just going to query for it. I'm just going to use your schema and just show the data here in my part of the software. But that means now that I can't change the schema anymore without having to worry about breaking somebody else's code. And I think that's maybe one of the biggest blocks that we have at our company, where we don't have that many inter-team dependencies, but those that we have, they're quite hard, I would say. And if we want to change something, it's not that easy. You know, we have to really collaborate with like 3, 4, 5 different teams, ask every single one, what do you use the data for? Can you maybe also use the data from somewhere else, you know, or can you get it yourself somehow? And this is a problem. And you don't see these things because somebody just calls the getter, you know, that queries the data, and you never see the code, and it's just there. And you won't see it until you break something. So yeah, that's one of the big cons that we have. It's also easy to meddle with other people's code, although you shouldn't. Yeah, I had that too, where people came to our code, changed something because they wanted to fix it. And then 2 weeks later, we had a lot of error messages and wondered, where do these things come from? And the investigation led back to somebody from another team, you know, changing our code and then not telling us about it. And just like, it was a single line that changed, but it was an important line. So yeah, we only found out because some things went wrong, and it's not good for our customers, right? Like we had some customers issues that way. So yeah, this doesn't happen in a microservice. You have your own service, you don't touch it, you know, that's it. All right. So we have the high inter-team dependency. You know, I said it earlier, it's, yeah, the dependency is quite strong. When I want to change something in my code, I still need to reach out to other teams and ask, do you need it? Do you use it? Can I change it? And the same way with implementing something new. You know, I want to implement something that also 2 or 3 other teams need to use. And then I need to ask them, so what do you use it for? What are your requirements? Is this a good solution for you too? And it just slows down your development process. And with microservices, you just build your own service, you throw the data, you have an event that you publish, you talk with the others about it, but in a more formal way, and that's it. You don't have to worry about it. Yeah, this is something that I touched on earlier with the last company that I worked for, because we had these giant spider in the web schemas. And that is, if you think about a user, the user, you know, is everything. Like if you, in our case, we have 20, 30 different teams, every single team uses a user. But not for every single team, they need the same data, right? As I explained earlier, we have invoicing, they need different data than payroll, they need different data than legal, and so on. And if you only have a single schema in the middle, you will add all this stuff to that schema. And well, if you then you have a lot of situations where, for example, you know, I talked about the onboarding earlier, and an employee needs to onboard to your system, and only then they can start working for you. And who says that, you know, the schema is complete? Like you have all that data in the user schema, and how can I know from another team that now we have all the onboarding data we need? Sorry, that was a little bit off topic, but this is a problem if everybody has the same schema, you know, because some people might start using it before the other team is ready with it. and so on. And maybe I say, oh, I need this data, but I need it in a different format, and I'm just going to change the format in the schema, or I can't change it in the schema. Anyway, it's a big problem. I talked about it enough, I think. Now, one of the last ones, if you have a monolith in a large company like we do, there's a lot more discipline required than if you have microservices. And that's because microservices, I said earlier, you have the hard separation between code bases, between responsibility and ownership. And in monolith, it's very vague. You can just call somebody else's code, you know, from the other side of the system. They won't even notice. Yeah, and you shouldn't. So it takes more discipline to enforce these things. There's some things, you know, people have the boundary library. There's a boundary library. We introduced it. Hasn't really worked for us so far, I think. It's one of these things where you don't really want to worry about that. You know, as an engineer, you have different problems. You don't like, the more and more disciplined you add to something, you know, the people won't use it, because we just want to get our job done and not worry about all these 10 different checkboxes we have to check. Yeah, so this is one thing that's a social problem where you need to, you know, say, no, we won't use it that way. You can only do it that way. All right, this has already been we have 2-3 more things. Yeah, in the monolith, we have all the tests in one code base. So if you want to run only your tests and you deploy it, all the tests need to run. So I said earlier, we need approximately an hour to deploy our code. In my previous company, it was 10 minutes because we had fewer tests to run. So same with compilation time, lots of code, longer compilation time, and it's hard to understand the business process. All right, this has been all of it, like, which one should you use when? This has already been very long, but I will try to keep the rest short. But maybe, do we have any questions? No, I don't see anything. Okay. All right, I will just go through this relatively quickly. Which one should you use? It depends. And on what does it depend? On different questions. You can ask yourself different questions, and then if you answer them honestly, you can maybe make a better decision which one you should use. So technical questions, which different parts of your software have very different requirements? So as I said earlier, we had some, in my last company, we had some services that needed to be scalable because we had a lot of users only on these services. And then we had a lot of other services that had like 100 users max, so no promote server. And in this case, it was handy to have microservices because we could scale only those and not worry about the rest. You know, it was good for our bill. Security, you know, if you have different services that need to be very secure, like if you think about payments, you know, you have like all these different services, and if a bad actor gets into them and changes some data, yeah, it's of course not acceptable, but it's not terrible, and your company won't die. But then you might have some core services in your company, in your system, that needs to be really secure, like payments, invoicing, anything that has to do with money. So they need to be more secure. They need to be, you know, have more authentication mechanisms in place and so on. And if you take them out into their own service, you can apply all of that to them, and you cannot have all this overhead of authentication in the other services. So different requirements. Yeah, elasticity, you know, sometimes you have some services which you need to deploy a lot, like you have a betting things, like a lot of bets coming in at the end of a football game. You need to have a lot of service just handling that very peak load, and others you don't care about. They can just be single instance. Anyway, long story. The next one, how does my existing architecture look like? If you already have microservices, you know, just keep adding them if it's okay for you. If you have a monolith, switching to microservices takes a lot of time. It can be gradual, but in the beginning, you need to set up a lot of infrastructure because you move from one server to two, and out of a sudden you need to reroute your traffic, do authentication, and all these kind of things. So it takes quite some overhead. So if you have one architecture, rather stick to it until you can't stick to it anymore, and then change. And yeah, do I already have different services in different languages? you know, if you already have some old Python, Java, whatever .NET services running, and you want to use Elixir now, yeah, it's easier to have new services in Elixir and then slowly kill off the old ones in Java, for example. If you have a monolith, yeah, you need to continue to write them in Java, you know, otherwise it doesn't work. All right, organizational things. I think these are actually quite important as well, because we engineers only think about technical requirements. But if you think about the company and the people, you also need to make sure that that's a fit, like the structure of your company with the architecture you use. If you only have one team, why do you need more than one server? Like, not server, but monolith, one code base. Maybe you need to, you know, do some scaling and everything. I understand that. But if you have like a web application, just use a single monolith, no problem. If you have many teams, it's already more difficult, you know, with like 30 teams. I think we kind of hit our the boundaries, and it just keeps worse over the years because we add code, we add tests, everything becomes slower. So you can go a long way with only monoliths, but at one point you might say we need services to make every team independent of each other. Yeah, the teams, can they actually work independently, or do they always have to work together? You know, you have two teams but working on the same feature. They can't work independently, so they can just as well work in a monolith. Do these teams work with the same schemas? You know, again, if they work on the same feature, same data, they can have the same monolith. If the schemas are fundamentally different, you know, you have the user schema and everybody understands the user schema different and needs different data, yeah, you might want to consider splitting that into different services. But you can also split it into different schemas first, right? There's a step in between. How many stakeholders do the teams have? If you have many stakeholders per one team, you will put all these stakeholders' requirements into the one code that you have, into the monolith. So if you think about one schema, yeah, out of a sudden you have payroll, invoicing, legal, HR, all of them need to have their data in the user schema, and it just grows and grows and grows. So in that case, you might want to have one team, but then create a microservice for each of these stakeholders, you know, payroll and so on, so that they can have their own data, their own flow, and so on. Yeah, how young is your company? You know, if you have just a startup, you know, better go with monolith. It will get you into the nice product niche and make some revenue faster. And can you afford the slowdown of development speed, especially initially if you switch to microservices? You know, to start with microservices, it always takes a little upfront work. It's not that easy, and it will slow down your development speed, at least in the beginning. But then maybe later you become faster again. You know, it's a trade-off there. So you need to, but if you're just like in the moment, you're hyper growth, you need to quickly push out code. It's not the best time to switch over to microservices. All right, one last thing about the Conways Law. The Conways Law, maybe you heard about it. The organization structure influences your system structure. So if you have a startup and everything is like in one team, you know, the legal person sits next to the salesperson, next to the payroll person. Yeah, it's a small organization. You know, they can probably all work in the same code base, one system, no problem. But out of a sudden, your company grows, you have all these different departments. You know, my company has over like 1,000 people now, a lot of departments. Yeah, maybe you want to split them off a little bit so that the 50 people working for legal can have their own system, their own data structure, and so on. Yeah, and if you don't have these clear team boundaries, you will get spaghetti code. Because out of a sudden, your legal code and data lies in the payroll part of your software and has to call the HR software too. So it's not very good. You should have clear team boundaries. And if you have, so what I'm basically saying with this thing is, if you have a better team structure, like if you organize your organization well, you will also have better software architecture, software structure. And that holds for microservices and monoliths, right? Especially if you have engineering teams dedicated for certain departments and you ask each team to work independently, you will have that split between team lines. And that's what you want in a large software. All right. One last part, just gonna rush through that. How do you build these two? The monolith, everybody of you, I guess, has already built one. You have a single user. You might have a load balancer in between. yeah, in our case, we use Elixir and LiveView as a backend and front end together. In other cases, you might use a front end as React, and then you have a backend Elixir. Very simple. If you have microservices, it's a bit more complicated. Sorry, this window is in the way. There we go. Yeah, it's a bit more complicated. In our so the first thing you need to do is have a reverse proxy. I wrote about that on my blog, how to set up a reverse proxy, and that's basically what it does here. Is if you have a front end app like React, you know, it needs to call like example.com/API/users. And if you, you know, you can use the reverse proxy to route these requests to the proper microservice. So in our case, you know, we have an API/landing, and if you make a request to that, it goes to the backend service 1, which handles landing requests. And then you might now have another route, like users, and then whatever addresses, and each that data and that logic is handled by different microservices. So you route that request to that appropriate service. That's the first thing you need, a reverse proxy. Otherwise, yeah, you need to have like stuff like service1.example.com, service2.example.com, and you don't want that. You want to have example.com/API/whatever. Yeah, in the backend, in our case, we had different background services with Elixir. You can see you can also scale them independently. Like the service 3 we can scale, service 2 we can keep. Each one of them, and that makes them a microservice, I think. Each one of them has their own database, but they also might to connect to the same database if needed. So these two, service 2 and service 3, they connect to the same authentication database for authenticating the request, for example. Yeah, and then all of them, I would recommend communicate through a message queue, and that can be RabbitMQ or Kafka or SQS, and that's where you send the events through. Yeah, and you might also have then some API calls between these services, but yeah, rather limit them to the utmost necessary. All right, I rushed through this one a little bit, but if you want to read more on this, there's some recommendations. First of all, the book by my boss, actually, Paulo Pera. He is my VP of engineering. He wrote a very nice book about microservices in action, where he goes through, for example, you know, how to set up something like this, like different pros and cons of different architectures for microservices. A book that I personally enjoyed a lot was Fundamentals of Software Architecture. Then there's a very interesting article by Herberto Grassa, Explicit Architecture. I also made a YouTube video about that one on my YouTube channel, Peter and Code, which I did like 2 years ago. I wrote a little blog post about how to use the CloudFront reverse proxy. That's what I told about earlier. Again, my video about explicit architecture. And I also gave a talk at ElixirConf 3 years ago, about event sourcing. So about the part like sending events and then keeping track of different versions of your data. Now, if you want to reach out to me, you can do that best on Twitter, PJ Ullrich. Otherwise, my blog is peterullrich.com. And with that, I would like to thank you very much.
That is nice. Thank you. So I don't know if anyone has a question. I think you can take 2 or 3 before we end the session.
Hello. Okay,
Hello.
so I have this confusion in me between the distributed system and microservices.
Oh, yeah, that's basically, I would say microservices are a distributed system. Yeah, but I guess you can also have a distributed system with a monolith, but usually it's about with different servers. Yeah, so it's more like, you know, if you, I'm not sure, like you have a user and then you have an employee and employer, like it's an abstract thing, which is called a distributed system. And then as a type, it would be a microservice. It's like an implementation of it, basically. No, sorry, It's not a microservice. Like a microservice itself is also just one server, right? But if you have microservices, like if you have the multiple of those, then it would be a distributed system. I hope that helps.
Yeah, that's helpful. Thank you.
Thank you, Tracy.
Right. So I can see that we're also out of time.
See, one tips on passing new members without microservices knowledge on onboarding. Tips on onboarding new members without microservices knowledge. I understand. Yeah, it's difficult. I would say honestly, the book here, Microservices in Action, is a very good one, but it's a bit more abstract. And then again, every architecture is so individual. So I would recommend, setting up a meeting with them, or having what I do at my company. I have these onboarding videos where I explain the product to anybody who joins the company. It also helps me to understand it better, and it doesn't take that much time. So I can recommend setting, like it's an hour max of videos where you make Loom videos in our case, and then you can explain how it looks like. And that might already set them off. I like to get them on the road quickly. And also it's a part of a developer experience too. If you have a new member coming in, and can they immediately push code? Your system, your whole CI/CD should be like that a new member can just immediately push code and don't have to worry about that, how it looks like and stuff, right? So that's my advice, also to make it as easy as possible, because then you yourself also have a benefit from that. You can just push your code, don't worry about it. And for new members, it's good too. All right, one more question from Alfonso. Top 3 strategies have succeed in your monolith to avoid or control dependencies or coupling code. Yes. In our case, we have namespaces, and we try to use them as much as possible. So I work in payroll. So every module I write basically starts with backend, like at our app, .payrolling. Something. And if you keep them apart, just the namespaces, that already helps. That's a good strategy, I think. Then, yeah, you have the discipline, self-discipline. If you see somebody else making a lot of random calls, rather say, no, I'm not going to accept the code. Try to get everything into your own part of the software. Third one is maybe use boundary. We are still evaluating it. It might work or not, but if you set it up early enough, which we didn't, that's also one of the problems. Like if you set up boundary, the library, early enough, it might help you in the future. It's one of these things. If you do it early, it's easy. Later, it's more difficult. All right. I hope that helps.
Great. Okay. So once again, thank you, Peter, and for everyone who has attended. I hope you guys found this presentation informative and valuable. So before we end, I would just like to remind us that we always have these webinars on a monthly basis. It's the last Friday of every month. And actually, we also have a conference coming up in May. So stay tuned. If you have further questions, please feel free to reach out to us. We always value your feedback. Once again, thank you for attending the webinar.
Thank you very much for having me.